Hey everybody, Michael Nass, and I'm here with John Bustos, owner and co-founder of Dr. Energy Saver Houston, and we're here on a new job site of his. It's how big of a house?
It's a big one, Michael. 10,000 square feet, pretty big house, 3 separate attics, 5 attic entrances, 6 air conditioning units, and just a whole mess of energy inefficiency, not to mention terrible, poor indoor air health.
So what exactly do you guys do?
So what we do is we take homes that are hard to cool, we make them cooler. We take homes that have lots of issues with dust. Also, newsflash, dust is not normal in a home, guys. I'm telling you, it is not normal. We take dusty homes, make them less dusty, if no dust at all, and then we reduce the life expectancy, we increase the life expectancy of the AC machines also, and we just improve the overall quality of the indoor air comfort, and we reduce the bills as well.
So to kind of get the gist of what you guys do, there's a lot of leaks in almost every house.
Right.
That your air conditioning is seeping out, heat seeping in, or in the winter, vice versa.
Right.
And running up your energy costs. And also, I guess there's issues with the ventilation of the, in the attics, where dust in the attics is sucked in. And so you can address both those situations.
Exactly. This particular home here has a couple of rooms that have attic space above it, floor space or vertical attic walls adjacent to them, with 24 to 36 inch openings between the subfloor, which below that is the downstairs master bedroom ceiling, and then the floor for the upstairs bedroom that's adjacent to the attic. So not only are these rooms getting hit by heat from above, heat from the side, infiltrating into the conditioned space, because hot is trying to get cold. That's the way that it is. It cannot be any other way. We find these areas, we test the home, we show you how leaky it is compared to the same home if it were sealed properly, and then we come up with an agenda. What is going to get you the biggest bang for your buck, and we attack it, and then we retest the home to show you exactly how good we did in sealing up your home.
And so what are you going to show us today?
So we're going to look at specifically this attic here. You know, as the heat builds up inside the attic space, it should draw cooler. Even if it's 100-degree air, it's still cooler than the attic air inside the attic space, but it draws cooler air in and displaces the hotter air that's in the attic space. This house has plenty of ventilation for fresh air intake, but there's nowhere for the air to be exhausted to. So that hot air is not going anywhere. It's boiling up, creating pressure, and it's finding, air is very thin, it's finding its way into all these building joints and assemblies, and we find those areas. We seal them up, push that air back down into the conditioned space where it belongs. We don't pay our AC bill to cool our attic spaces. So why should we have ACs that leak? Why should our homes leak? It shouldn't be that way. We come in, we find all that, offer you the solution, take care of it, and everybody's happy when we're done.
All right. So the guys are hard at work up there?
They're hard at work right now, yes sir.
Let's go see what they're doing.
Let's check it out.
All right.
So earlier we said that there was 3 attic spaces with 5 different entrances in this home. So right now we're in what we call attic number 2. Attic number 1 has already had most of the retrofit done. We'll check that out here in just a little bit. But you know, one of the major issues was a lot of dust. The maids that cleaned the home said that they would clean one day, the very next day there was dust everywhere again. The wife, the kids, lots of allergies. So one of the main things, one of the main concerns that the homeowner had was the indoor air quality. Because of the air leaks in the AC system and whatnot, we decided it was best that we remove all the insulation, and we're vacuuming all the ceiling areas that the insulation was in. So after we do that, we're able to expose a lot of areas that are losing air. Come on, why don't you check this out. So we say that we base our findings to, you know, our measures, whatever we are recommending is based on, you know, what we found, and we base that on building science and physics. So we're in attic number 2. It's not as hot today. The attic doors have been open pretty much all day. We're moving insulation and whatnot. But if you can look down here, this is a cavity between, you know, 2 walls in the home that goes all the way down about 18 or 20 feet in length, and also 18 to 20 feet down. So it's hot in here. Hot is always attracted to cold. Look at the temperature here. 84 degrees, so and then when I measure in the space, it's 10 degrees less down there. So that heat is trying to get to that cold and consume it, because hot is always attracted to cold. The AC will continue to run. So we're going to stop the bleeding where it counts. We're going to push that air back down. We find all these areas in the house that are leaking air, including the AC and duct system, and you'd be surprised the comfort and especially the savings. So what we're going to do is, this is some boards that Dr. Energy Saver has made specifically for us. It's called Silver Glow. It's an R20. It's a EPS graphite infused foam with a radiant barrier on each side. So we're going to cut it to fit and then foam over it to make sure that we're not gaining any heat and losing any air from the conditioned space. So you can see we haven't vacuumed up here now. Let me go show you some of the finished product. So this is the first of the 3 attics of this home that we're working in, 11,000 square feet, 6 air conditioning units, and we're almost done in this attic. So we keep saying that we base things on building science and physics and how hot is always attracted to cold, high pressure, low pressure. I've been saying that part of the problem for this home is that the hot air that builds up in the attic space, it cannot be exhausted anywhere. So watch what happens. Look at this plastic right now. As soon as I open up this door, it's cool in here. Let me see what at least the surface temperature of the floor is. 69 degrees, almost 70 degrees. Wow, 78 degrees. Wood is not a very good insulator, by the way, so you can imagine what's going to happen. Check this out. Look at the plastic. The hot air is being drawn in to this cool conditioned space. Hot is always attracted to cold. So the heat is basically waiting for this door to be open. Not only is it inside attacking all the sheetrock, and here's the problem. You've got a bedroom here that has vertical attic walls with heat that builds up intensely with no place to go. All the heat was being attracted underneath these floors, which was affecting the master bedroom and also this bedroom and closet that we're in now. So tomorrow that problem will be totally taken care of when our solar attic fan is installed and is able to get the right air exchanges into and out of the attic space. So one of the things that it's important for this particular home, we don't do this with every home, but we installed radiant barrier even though it had a radiant barrier backed wood decking. You think about this, you've got thousands of nails driven through this wood decking that has radiant barrier on it. It starts to peel. This was the same as every other home we go into. Our website has in our photo gallery pictures of the decking with radiant barrier that's glued to it. For radiant barrier to work, right, there has to be at least a ½ an inch of an air gap. So the stuff that was here is laminated, glued to the bottom of the decking. With the heat, it starts to delaminate, all the nails driven through it. It really isn't great at all. And I'm going to show you, I'm going to prove that to you right now. We got an infrared camera. So we have radiant barrier installed on the bottom side of the roof rafter. So what we've done is we've taken the thermal boundary and moved it up. We're blocking heat out, radiant heat, and the rest of the insulation is working for the conduction, convection type heat stuff. So check this out. This is a huge temperature difference, and it's not even 90 degrees outside. So the hotter the day, the greater the temperature gradient, the more reflectance there is for this radiant barrier. So the more effective, the hotter the day, the more effective it is. So I'm just going to place this thermal camera right back here behind the radiant barrier, and we've got spots from 125 degrees to 132 degrees, and I'm going to come underneath here on this side of the radiant barrier, 85 degrees. So 85, 125, that's a pretty big difference. I mean, so that alone is going to take a huge heat load off the AC ducts. It's going to take, even though we've sealed them all properly, but it's also going to take a heat load off the skin temperature of the ducts. They're going to become more efficient. The machine is not under the heat load that it's been in. The one thing we haven't done is getting this heat out. So it's a little bit hotter than what it should be in here right now. Once we get the solar attic fan on, it's going to give us those fresh air exchanges in the attic space and take the heat out continually, especially when it's the hottest. The fan is turning, it's moving that air. The air is staying in the AC and duct system. The delivery temperatures are what they should be to the room. Now you've got a house that's more comfortable evenly throughout the home, and the bills go down. Remember, almost $1,600 a month here. Before we did work to this area here, all these spaces where the radiant barrier is down here, that was open, and it's open between, you know, the ceiling of the master bedroom and the floor of the bedroom that's just adjacent to this attic space. So this room here has an attic above it also, so it's getting heat load from the attic on top. None of the attics have any ventilation, but they've got beautiful fresh air intake at the soffits, but nowhere for it to displace the hot air out. So that heat was just getting into the home, making everything very uncomfortable. We've got underneath there and sealed stuff up really good. Put barrier over it. We're trying to keep as much heat out as possible. And again, when we get the solar fan in, it's going to be amazing. We'll be sure and get back with you guys to show you exactly what type of difference the homeowner says that he has on bills, and as far as the comfortability and indoor air quality, all the dust that they had after we complete all the work. So one of the things, Mike, too, that's really, you asked, you know, what's different about Dr. Energy Saver, everybody. So let me tell you something. Let me show you something, actually. Right over here, when we were removing the insulation, we found a couple of areas, and back in here, it's covered with radiant barrier right now. But what it was some areas that went real far down that I know they were leaking a lot of air. So I thought, okay, well, I can easily get over here and come across, but I can't because there's a beam here. So what the guys did, you can see here, we notched out these boards that aren't structural or anything between this little, you know, rafter or joist bay, and they were able to get in there and air seal and then put radiant barrier over those large voids. So we're in the third attic and we've got the AC running. This is a prime example of why things are the way they are, probably in your attic too. You know, the sad thing about this is that this is something that the AC installation crew did. They punctured a knockout for the control wiring on this AC, but they created a problem also. You can see anytime that this unit is running, we didn't have the smoke pencil, we'd never know what was going on. This is just one area that this machine is sucking in hot, untreated, dusty, a lot of times allergen infested attic air into the system. Several problems with that. The machine is designed to handle only a certain amount of cubic feet of air per minute based on the area that this machine is serving. So that's in the conditioned space, but here's the issues. We're taking in a lot of extra air. It's dirty air, so it's the coils are getting filthy. The amps run higher because the coils aren't as efficient. And like I said earlier, the life expectancy of the AC is cut way down. So we come in here, we seal all these areas up. One of the only AC companies that I've seen that will seal up even these sections at the machine. So every AC, almost every house we go into, we take over the AC service. So we know how we seal them. When we go and service the machine in the spring and in the fall, we can take it apart and then seal it back up to where it's not sucking in all this extra air. That's one issue. This is the negative, the return pressure side. So we're paying extra to condition air that we're not even supposed to be conditioning, and then we're paying extra because we're blowing out the cold air that we're paying to cool already. So we're sucking in air we're not supposed to have. We're blowing out air that we're not supposed to be blowing out. This is just one area. This is just an inspection port for the evaporator coil. And you know, it's crazy because whoever put this in, they put mastic here, but why wouldn't you put mastic here? I don't want to pay to air condition my attic space. That's not what the ACs are supposed to be conditioning anyway. That's exactly what's happening in this instance here, and in almost every home that we go into. You can see it's blowing the smoke out here, so it's blowing air out and it's sucking extra air in here. That's just one piece of the puzzle. So what we're doing now up here in this third attic, you know, lots of dust. The guys are removing the fiberglass insulation bats. There's a lot of dust in them. You can see here, if I just do like this here, you can see how dusty this is probably one of the dustier attics I've been in, and I believe we go in between 700 and 1,000 attics a year. So basically the guys are just removing all this fiberglass insulation. There's a ton of dust in the insulation itself. So we're getting rid of the insulation, then we're going to come back and we're going to vacuum everything out in little quadrants or sections so that we can remove the majority, if not all, hopefully all, the dust that we can at least, that we can get to. So we're removing the dusty insulation, we're going to vacuum it, and then we're going to seal the house up, come back with fresh brand new insulation.
The tour showing us what your guys are doing up there.
Thank you, Mike.
That was really very interesting, especially in that one area where you show you guys had applied the radiant barrier.
Right.
And it was 124 degrees on the side of the radiant barrier to the roof, and only 84 degrees in the treated attic area.
It makes a difference, but it's not the only thing. You know, the house is a system made up of several subsystems. When one of the things, radiant barrier is only one part of the solution. It's not even the main part of the solution. To me, it's the icing on the cake.
If I or anybody wanted to get a free energy audit from Dr. Energy Saver Houston, what would I need to do?
Well, they could just call us at 832-524-9600. That's 832-524-9600, and they can talk to one of the call intake associates, or they may even talk to me directly. You never know, if I answer the phone as well. But just give us a call. We'll be more than happy to set something up, come over and show you exactly where you're losing and where we can save you.
And the website's Dr. Energy Saver Texas?
Dr. Energy Saver, so it's Dr. Energy Saver, S for South, TX for Texas, drenergysaverstx.com.
Thanks again for the show what you guys are doing, and stay tuned to your social media and the website. We're going to have some before and after bills, electric bills on this place.
Yeah, we'll come back and see how good we did.
Awesome.
Awesome. Thanks again, Mike.
Yes, thank you.
Thanks.